Hi everybody, good evening. This is Rameshwar Nigam, and today we would be discussing about wireless security, and we're going to go through a lot many things in terms of wireless security, not only from a factor of uh, the the 802.11, but also which we normally call it as Wi-Fi. But also we're going to go ahead and talk a lot about Bluetooth Low Energy, and other wireless security feature set. So when we go ahead and talk about the agenda today, what we're going to cover, we're going to go ahead and talk about what we are, which organization do I represent, the various wireless security vulnerability which are there, the IoT protocols and the vulnerability which are aligned to those wireless uh, protocols, and then finally how to avoid those security breaches. So this is pretty much the agenda for us for an hour, and let me go ahead and also open up the URL so that we can, if there are any particular questions or something, we can definitely go ahead and address to it. So when we go ahead and talk about wireless security, the first thing which comes into our mind is, can we actually achieve anything like wireless security? And before we even go and talk about the wireless security feature set, we would like to go ahead and talk about how does a wireless function, and pretty much from the wireless perspective, I'm talking about the day-to-day wireless connection we do from your laptop, from your mobile phone, and not the data you're using from Airtel or Geo, but the one you are using when you get connected to your home, and automatically you get connected to your home router. So once we have been able to completely go through this entire wireless traffic, we would then go ahead and try to deduce out the loopholes which are inherently there in wireless traffic and wireless analysis. And once we are able to do that, we can move towards the various vulnerabilities, and finally how to go ahead and try to avoid it. The terminology which we are going to use is pretty much taken up from the IEEE 822.11 standard, which is as we say, the mother lode for any wireless interaction. And if you look at it, these are the particular thing which we go ahead and talk about in terms of the wireless association. Let me go back to the slide again. I kind of rushed to the slide. So basically when we go ahead and talk about, we actually talk about in terminology station, BSS, that is the basic service set. In basic service set, and I would say, do not get into the complexity of the terminology. Rather look in terms of what exactly it means. So from a station, we mean wireless client. We also mean the access point or your wireless router to which you are getting connected. Basic service set is nothing but your SSID, which you like to go ahead and connect with. It could be Airtel, it could be Geo, it could be some fancy SSID you would have kept. As a matter of fact, if I go ahead and show across the wireless connection here, you can easily go ahead and find out a lot many wireless SSID which would be available. Then you have your uh, extended service set. There's a set of connected BSS, and uh, in BSS itself you have infrastructure BSS, that is the normal way we go ahead and connect to your access point and the clients which are getting connected. Alternatively, you also have this ad hoc networks, which you would have seen at a lot many times when your friends would like to go ahead and get connected and they don't have that kind of connectivity. You open a hotspot, and when you open up a hotspot, you basically or primarily use independent BSS to go ahead and get connected to each other. Finally, there are BSS and the DS, which is distribution system, which connects the APs in an ESSID. So these are the various terminology which we go ahead and talk about when we deal with the wireless connectivity. Now, here is how the AP connection take place. Well, the moment you open up your, or you get a new laptop, you get a new mobile, and you open up your wireless, the wireless NIC sends a probe, and it sends a probe to go ahead and find out or seek out what are the available networks to which it could connect to. And it, by new, it doesn't mean that you always have to get a new wireless device to get a probe. You can also go ahead and get a probe if you move from one of your common wireless ecosystem to a new wireless ecosystem. So let's say you can easily go ahead and automatically connect to your home, but let's say you move to your friend's house and you try to go ahead and connect to the wireless network. The first thing what you would see is that, or happen is that there would be a probe request which would be sent, which is being sent with a response from the AP station. So that wireless router is going to go ahead and send the probe response, and along with the response it would also inform the trying to connect station that, hey, you know what, I am configured with WPA PSK, or let's say I am configured with WebKey, or let's say I'm configured with Eve. So I would like to go ahead and ask you to start attempting that authentication, so that once you are able to go ahead and attempt that authentication successfully is when we can go ahead and get connected and get you into the network. Well, since the IEEE draft was done way back in somewhere around the 90s, you didn't had WPA, WPA2 at that time. So the way the authentication was configured was that there would be an open system authentication request inherently configured inside the 802.11 packets. Now, let me be very clear on the fact that this open system authentication request is no authentication. It is zero authentication. Anybody, any client which has been configured to do an 802.11 response probe would easily go ahead and clear that. So this does not becomes basically a doorstep or a door wherein you can stop somebody. This is just to go ahead and put across an authentication request. This authentication request gets an authentication response to which the association request has been sent. Now, here is where you're going to go ahead and put the security parameters. So your friend or whosoever is the concerning administrator of that home router or wireless router would share the password and would say that, you know what, this is the 8 or 10 letter password which you need to go ahead and put on your device. It could be your mobile, it could be your Mac, it could be your laptop, through which you can get connected to my wireless connection and get into my home network. So you now put in that particular password, and this is how you're going to go ahead and send the association request. The moment the access point station get the security parameters, it validates the WPA PSK or whatever the authentication parameter is, it goes ahead and associate you. So if you look at the various stages AP connection packet, the very first stage is unauthenticated, unassociated. That is, let's say you get inside a new wireless ecosystem, or you go to an airport and you would like to access the free Wi-Fi. You open up you fire up your wireless connection. You see there are 15 different wireless network which are available, and we are going to go ahead and talk about that also, that how come you see 15 wireless network. You see there is one which is a free Wi-Fi of the airport, and you try to go ahead and connect. So while you are trying to connect, the state is unauthenticated, unassociated. Well, successful authentication happens, the state changed to authenticated, unassociated. Successful association or reassociation happens and the state changes to authenticated associated. Now, a question can come up during the discussion is that, well, if I'm getting authenticated, then what's the need of this two-state factor of authenticated unassociated and authenticated associated? Well, let me share this to you in a deeper, in a much clearer way, so you'll be able to understand. A mere authentication does not mean that you would be getting associated to. A mere authentication simply means that the access point opens up the door for the network. Now, a lot many things happen when your client is trying to connect to an access point. While the security parameters are being shared, there are other parameters like RSSI, which is receiver strength signal index, or signal noise ratio, which is SNR. All these factors come a lot into play. If you think about it, an airport would not have a single access point, it would have multiple access points, throwing out the same SSID with the same security parameters. Now, how would a client decide? And what is the reason or the rationale behind the client deciding that which particular access point I should connect to? To answer this question, let me put it in this way. A client is has its own sense of mind, has its own sense of rationale, has its own sense of algorithm to which it decide on which access point or to which access point it is going to latch onto. And unfortunately, there are no particular set standard put across by IEEE. So different vendors used different algorithm for the client to latch onto an access point. Now, few of the client may simply latch on with a better RSSI, while few of the client may go ahead and take a balanced view between the SNR and the RSSI, and then probably go ahead and connect to a particular access point. Mind you, this is important because in a real life scenario, when we deploy wireless access point, a lot many time after the deployment, the client comes up with an issue of a sticky client. And by sticky client, we mean that access point simply goes ahead and latch on to a particular access point, or a client latch on to a particular access point without going ahead and doing anything, or without changing anything, or without, as a matter of fact, even looking at a better RSSI. So when the client get back to us stating that, hey, you know what is the logic behind it, and why is it that we see that clearly the client is not latching on to a different access point? To be honest with you guys, we really don't have a particular answer to say, or we cannot go ahead and share out any answer for that particular reason. So one of the issue which we do face in the current scenario in a real-time world deployment, sticky client is a big time issue. Anyways, so getting back to the same, as and when we see that a client has particularly served out the purpose, before it logs off, it would send a deassociation, which would move forward to the authentication notification. And here are the various frames which are exchanged during the different stages. So class 1 frames during the unauthenticated unassociated state. Now, if you would remember, we talked about a probe request. So you can clearly now understand where would the probe request actually come from, or which class would it actually come from. Similarly, class 2, class 3 would also go ahead and work on the same way. Class 1, class 2 is also going to be something which would really help us out, as well as the class 1, class 2, class 3 frames are the last 3 frames which you could clearly see. Okay, so once we are done with this, Let's move to the next slide. And here, when the authentication happens, it would go to the same state, that is the state 1, which is unauthenticated, unassociated. I would say don't get into the each and every packet or the packet header. Simply go with what all comes when we go ahead and look at a WLAN packet header. We talk about a frame control, we talk about a duration ID. You got the address 1, address 2, address 3. That is your sender address, receiver address, the BSS ID address, the sequence control, the address 4, the QoS control, the frame body, as well as the frame check sequence, which is the FCS. So if you go ahead and look at it, pretty much anybody who would have seen a particular packet in any of the, be it 802.11 or be it even a TCP IP packet, you're going to realize out that they pretty much functions in the same way. You don't have a lot many thing changing from what we see here: frame control, duration, address. Even if you go, this is I would say a WLAN packet header, but if you go ahead and look into a TCP packet or an IP packet, you will pretty much see similar kind of things. You will see a receiver address, a transmitter address, and some other things which would go ahead and make the IP layer the way it should function. Now let's get down to the major attacks which are there, which are available in a wireless security or a wireless network. Well, first, DOS, which is denial of service. The second is MITM, man in the middle, and the third is evil twin, or we also call it as rogue AP or rogue access point, which talks about also a fake access point, which we are going to go ahead and discuss. So what is a denial of service attack? Well, there are two ways you can set up a denial of service attack: the layer 1 DOS attack, unintentional interference. Now if somebody has a background, what I would like to know if somebody could give me an example of unintentional interference in an 802.11 networks. Can anybody, if somebody has a background or somebody has read about it before, in an 802.11 network, can anybody tell me what is unintentional interference, or what would be one example, pretty common example of an unintentional interference? Anybody? Okay, well, let me just go ahead and share it out. But plain and simple, uh, and this came up with one of the examples during deployment. My client, we deployed an 802.11 solution, and this is pretty much in the year 2006-2007, when 802.11b clients were there, pervasive. Everybody used to use it, and the client had an interesting situation that during 12 to 2 p.m. the wireless network used to go down in the office, and after 2 p.m. it used to come back up. The internet used to be slow, and every other person you go ahead and talk about during that interval used to face wireless connectivity problem. Well, a lot of things were done, few access points were added, few access points were moved, antennas were played around with, but the conclusion came down for was that there was a microwave oven. During 12 to 2, all the guys used to use the microwave oven for heating up their food or making sure that they are eating up something warm. Now, microwave oven works on the same frequency, which is 2.4 gigahertz, on which your 802.11b predominantly works on. So whenever during the lunchtime, when there was a heavy use of microwave ovens, the internet used to go down and it used to be slow. After, as and when the 2.4 gigahertz devices were not used, the internet used to be back. So the context is, inherently, if you go ahead and look at it, wireless has a lot of challenge in terms of intentional and unintentional interference. So what is intentional interference? Well, very simple. I know that your device works on 2.4 gigahertz. I make sure that I brute force that particular frequency channel with with a high frequency device which is constantly probing or sending request. Well, that is going to go ahead and block your channel for that particular zone, and you would not be able to connect. Similar is the attack for which is known as Queensland. If I look at a layer 2 DOS attack, the first thing which comes into the mind is illegal channel beaconing. You take a channel. Most of the wireless access point are configured on the non-overlapping channel of 1, 6 and 11. So whenever you're going to go ahead and use this, you're going to find out that this is a common attacking point for attackers, that they would choose one of these channels and then they're going to flood it with a request or flood it with a probe, and that would simply go ahead and disable the entire wireless access point connectivity. The second and third are kind of aligned. That is what we discussed, the probe response and the association flood. The fourth one is a fake AP. Now, when I go ahead and look at it from a fake AP perspective, this is again interesting. Now, we discussed initially that wireless client is, and I'll be very frank, honest with you guys. Kind of lived the same kind of and have gone through the same kind of journey. Wireless client is like is like a girlfriend. It would have its own sense of mind. There would be multiple people who would try to go ahead and chase. The girlfriend decide to who she is going to go ahead and maintain the relationship. Now, fake AP, interesting, is kind of a man in the middle, is a person who would kind of imitate similar characteristics of the access point to which a client is connected to. However, would be much easier to connect because the security features would be completely down. So let's say you've got a home router and you have a SSID, say Airtel, and as you are engineers, computer engineers, and you know the value of security, you set up a 15 character WPA PSK, which is hard to crack, impossible to crack. Well, I cannot go ahead and brute force your password. So how to go about making sure that I still go for a denial of service attack? Here's the deal. What I'm going to do is I'm going to create a fake access point with a MAC address, let's say again fake A, and I'll create the SSID as Airtel again. Well, nobody can stop me. That's not illegal. I can anytime go ahead and use whatever SSID which I want to. However, I'm not going to go ahead and add any security feature to it. As a matter of fact, I'll also make sure that my fake access point is kind of close to the client, which is always catching up with the older access point. And then I wait. Now hear me out, guys. This waiting part is one of the precious gem a hacker should have. Be it when you are cracking a WPA2 PSK, be it when you are cracking a leap, be it when you are actually doing a brute force. After doing a certain set of activity, you have to actually be patient enough to go ahead and let the probe as well as the response as well as the association do its job. So I wait. And what would happen is my client, which has a certain set of algorithm, is going to go ahead and choose, well, you know what? I have always maintained a relationship with Airtel with a 10-figure PSK. I see there's a guy with the same Airtel but with zero WPA PSK keys.
There is no authentication. How about latching it to it? And furthermore, the signal strength which I'm getting from this access point is far better than the one through which I am always connected to. And that is where your disassociation happens. The probe request gets in and your clients gets connected to the fake access point. Now, if I am as smart enough as creating a fake access point, I'll also make sure that my network would have a Reliance Jio or some kind of connection which is NATed to the network, so that now you will be getting all kind of internet you want to because I have a valid connection. However, I will be the man in the middle between you and your internet connection. I hope I have been very clear about how would you go about on what exactly is man in the middle here. So when we go ahead and look at this, this is something wherein we talk about how you create a fake access point. So we discussed this man in the middle. Here is the man in the middle in detail. The target laptop unintentionally connects to the rogue access point. The rogue access point can intercept the network communication, and as a result, the attacker could read, modify sensitive data in transmission. Can I go ahead and read your password? Well, yes, you can. Can we go ahead and demonstrate it right away? No, that would come later, and we would definitely go ahead and demonstrate. Not now, not today, but yes, probably in one of the few of the later discussion when we will be talking about Metasploit and how can we go ahead and use other phishing attack. But am I not a man in the middle? Yes, exactly. Because right now the access point to which you are connecting to is pretty much my laptop, which is a fake access point for you. So given the right set of software, I can easily go ahead and make sure that I am the person who is intercepting whatever you are doing at your user interface, and if required can modify and manipulate it. This is your rogue access point attack program, and what are the potential risks? Well, I don't have to discuss in detail about this. You all know it very well. But come to think of it, why would I like to go ahead and do a rogue access point attack? Well, first thing first, it would be probably for fun to make sure that everybody knows that, you know what, I have that kind of skill set of breaking into your network. But apart from that, let's be serious. When we look at the real world scenario, data theft, data destruction, and I don't have to even tell you about data theft, data destruction. If you open up the newspaper every second day or third day, you're going to find one or the second odd issues coming up with data theft or data destruction. Well, data destruction is something which most of the people do not report, because then it becomes a real-time issue of legitimacy of the entire ecosystem. Data theft is still something wherein you can go ahead and fall back on weak security or somebody internal which may have caused the issue. Malicious data insertion. Well, this is even more worse, and third-party attacks. And let me tell you, I have been through one of the live attacks wherein one of the healthcare giant, they went through a malicious data insertion. The SQL injection happened. The attacker was able to reach to the server, and instead of destroying everything, what he smartly did was he simply encrypted it. And the encryption was strong enough that none of the local people could actually go ahead and break it. As a matter of fact, he was constantly changing it because there was a connectivity. What he simply asked was few thousand bitcoins. I am not sure, and neither I have the ability to go ahead and discuss with you what happened and whether the organization did share the bitcoin or not. But let me put in this way, the guy was successful enough for 3 days to create a denial of service, because a total strength of 57 engineers and engineers at all level, web designer, web integrators, database administrator, were not able to get the data, were not able to use the database because of the encrypted server, and nobody was able to go ahead and get the server up and running. So this is real time. It's not only something which is happening in US or somewhere. There are multiple people who are doing it, and the safest way to go about this is wherein you have to be only cautious. There is nothing else. I'll move to the other form of wireless protocol, which is Bluetooth Low Energy. And if you want to know one of the common devices in Bluetooth Low Energy, anybody who is using an iPhone, all of these iPhones nowadays come with the BLE 4.0. And to know whether you're using a Bluetooth Low Energy, very simple. Fire up your Bluetooth and see if the Bluetooth can connect, your phone can connect to multiple devices. If it can, well, you are actually using Bluetooth Low Energy, which is 4.0 and beyond. The Bluetooth BLE 4.2 have the capability that it is backward compatible to 4.0, and it has also the compatibility that multiple devices can connect to it. So long time back, the Bluetooth, when it started out, it had this limitation that it could only go for a one-to-one connection. Well, that has been done away with. Even the speed kind of has increased, and they do talk about 2 Mbps speed, but then there's a trade-off of distance, which has always been there with Bluetooth and which is still existent in Bluetooth. So the moment you go beyond 10 and in certain cases 15 feet, you're going to see that that it is going to create this issue. I've got few questions. What if the request is an encrypted request like HTTPS? What you're talking about is a different layer when you talk about HTTPS. When we are talking about wireless LAN connectivity, we are working on layer 2. Let me see if I can go ahead and wire it down here. I'm not sure whether this is going to work out for me. But if it does, wait a minute. Let me close this out. Okay, yeah, I am able to right now. So, yeah, so this AP connectivity, when we go ahead and talk about, is pretty much layer 2 connectivity. So, what you are talking about in encryption or HTTPS is layer 7. So, you are actually talking about two different things. When an access point and a client is connecting, we are talking about MAC addresses being shared, and this is your HTTPS is way beyond. When you've already got an IP, you're connected, layer 3 done, layer 4 and layer 7 are started. Will a device automatically connect to a new AP? Okay, so technically uh, connection needs to be clear. I mean, by connection, if you mean association, yes, because you can see the MAC address. Uh, but if you talk about authentication, no, you have to go ahead and put in the right security parameters to get connected. Okay, I mean there the change of security will not automatically connect to it, right? You're right. As I said, that if the security changes, you're pretty much off the grid. You cannot go ahead and get connected. So let's get back to the yeah. So Bluetooth Low Energy. Now, Bluetooth Low Energy has an entirely different concept of getting connected wirelessly. I'm sorry if I was kind of low into audio. I hope I'm clearer now. The difference between 802.11 and Bluetooth Low Energy is 802.11 works on a different spectrum, which is DSSS, direct sequence spread spectrum, while Bluetooth Low Energy works on FHSS, which is Frequency Hopping Spread Spectrum. How does it work? Well, simple. If you go ahead and look at a blue energy sniffer, when we go ahead and train, and I'd like to go ahead and talk about my organization and myself when we are done with this. So during training, we actually give you a Bluetooth low energy sniffer so that you could see the hopping. And if I remember correctly, if I'm right, in 1 second there are 1500 hops which takes place for a Bluetooth low energy packet. What are the advantages? Well, you remember we talked about intentional and unintentional interference causing a denial of service. Intentional was I flood a particular channel and that would create an interference. Now think about a frequency hopping spread spectrum or Bluetooth low energy. It is inherently designed in such a way that it would not at all go ahead and be affected from the intentional interference. There's one more question. Original AP was WPA2, say now our new AP is open. Won't that cause issues? The device will not automatically connect. No, it will. Not about automatic, but yes, it will. And especially since you brought this up, I wanted to cover it up later at the end, but I'll still go ahead and share it out to you, Ayush. It's not only your access point, and that is why I wanted to start the terminology first when I said station. And I clearly told the station is not only your wireless access point, the station is also your client, your mobile, your cell phone, your iPhone, your Samsung. Why? If you clearly look at it, when you go ahead and open up the Wi-Fi in around yourself, not only you see SSID around you, but sometimes you even see some of the SSID which are, or some of the SSID or keys which are already there, or which you see that they are not meant for access point. Why do you see it? Well, just like your access point is prone to a probe, similarly your wireless device, any of this, would always send a probe request. So what happens? Whatever SSID you have saved in your mobile as getting connected to it automatically, what it simply does is the moment you get into the vicinity of this particular wireless network, the probe simply gets connected to the access point. What does that mean? How is it that the moment you get inside your home and you are automatically connected to your wireless network? How does the access point comes to know that the moment you get inside the home, Ayush is there and he's getting connected to the wireless home network automatically? Well, there's no magic to it. These probes are always there, and I've shared it out during my various training session to all the audience. The silence what you feel which is there all around you, it's a myth, because the moment you start looking at the wireless traffic as well as the Bluetooth traffic, you tend to realize the amount of data which is there, which is pervasive all around you. So all of those particular SSID which you have saved to connect automatically. So let's say you're working somewhere, or let's say you are in your college and your college Wi-Fi has a particular SSID through which you connect to. When you go to the airport, not only you are seeking out for a SSID to connect to, your mobile is also pushing off the same probe which has been saved as automatic connection. So if I'm using a right wireless card, I can easily see all the SSID you have actually saved or you have actually connected to. As a matter of fact, we wanted to do a practical, and probably I'll work with Ayush. How can we go ahead and do the second part of it? It also will be based upon the kind of response I'll get from this particular live webinar. But I would like to demonstrate the fake access point, the kind of probe your single wireless mobile or your mobile actually sent across to all and sundry. And why is it that after reading wireless security, I have now decided that I don't have an automatically connection or automatically connect to my home network either on my laptop or on my phone, because I know a, a smart guy with 600 rupees of a Tenno card can easily go ahead and can decipher what kind of SSID I like to connect to, and can then go ahead and work his or reverse engineer his way back to go ahead and do the kind of attack what he wants to. Well, I'll move towards the Bluetooth low energy connection diagram. It would look complex, but it's pretty much simple. The Bluetooth low energy, the way it works, if you would have now come to the realization that wireless is all about probing, well, let me introduce you to the world of Bluetooth low energy, and you're going to realize out that it is all about advertising. It sends so many of advertising packet in a particular second that it gets flooded. It looks for a connection request, get the peripheral or the central, the data exchange happens, and you get connected. Now, I'll simply go ahead and move from the Bluetooth low energy stack to the Bluetooth vulnerabilities. And what are the vulnerability? Well, first of all, data transmitted is clear text, which can be sniffed. And that is true. Not only this, most of your Bluetooth low energy enabled devices, like your watches, and uh, Apple has now recently come up with a better iOS. So now you cannot actually go ahead and do those particular kind of attack which you could have done in the initial watches. Otherwise, there are still a lot many watches in the environment or in the ecosystem which works on the security called just works. And I'll go ahead and write it down, type it down. Just work is one of the common security which, as we say, is basically no security at all. It is all four zeros or all four ones. It has been pre-configured that any wireless client or any wireless watch would actually go ahead and get connected to this using just work. So if you ever go into the market and you go ahead and find out that there is some Bluetooth low energy device, let's say a Bluetooth phone, let's say a Bluetooth speaker, and if you go and look at these into the finer print and you find out that the security feature is set to just work, well, you don't have to be a great hacker to go ahead and hack it. Just put in the four zeros or four ones, and I'm sure you would be cracking it up and you would be the faster one to get connected to that watch rather than the person who's supposed to use the watch. Now, advertisement snooping, sorry, the spelling is it's not snooping, snooping leads to denial of service. Well, if I go ahead and find out that this particular client is actually pushing across the advertisement, I just go ahead and snoop it, and then finally I could even use a replay based attack to go ahead and make sure that the attack creates the denial of service. Man in the middle still exists with Bluetooth low energy too, and as I mentioned, cloning the device is something which is already there. Here is the other variant of 802.15.4, which is called ZigBee. This is another wireless protocol which is extensively used in IoT devices. As a matter of fact, initially when the devices came from Internet of Things perspective, a lot of them you are still based on ZigBee. So your wireless webcam monitor, baby monitors and all, most of them come with the ZigBee. So ZigBee kind of have differentiated themselves a little bit from the 802.15 and 802.15.4. However, the inherent characteristics of the interference, because it also works on the same 2.4 gigahertz, lies. It's found in most of the smartphones. Well, now the smartphones have moved to Bluetooth low energy. It is again the short range, and the way it works is it creates a mesh network to extend the range. So And finally, I would also like to go ahead and discuss, since somebody talk about HTTPS, so I would also like to go ahead and discuss what are the other web application vulnerability when you talk about the wireless security and security. And since HTTPS was brought, SQL injection, command injection, uh, RFI, serialization bugs, XSS, that is cross-site scripting, are few of them. And trust me, you don't have to be a tremendous hacker to go ahead and do any one of them. Each of one simply requires the attention in terms of the packet level discussion or description. So if you know how the packet behave, if you know that if a deauthentication request or deauthentication packet is been sent from an access point, it goes as a broadcast and all the clients would be disconnected. Well, that's very good. That means that if you could induce a deauthentication packet, then all of the clients which are connected in the vicinity are going to drop off. Can this be done? Yes, it's very easy. Is it legal? No, it is not at all legal. So if you go ahead and try anything of this sort around your live network and you don't have a lab network, well, I am not the one who recommended this. So this is something which is there and which has always been an issue. Well, this presentation was not to, or deck was not to go ahead and scare you of wireless network. It has its own flexibility, and that is why you see 90% of the IoT devices using wireless security and wireless networks. So how to avoid them? What do we do? Well, the very first thing is do the auditing, and do the auditing at the right layer. I am using, and as somebody pointed out, I'm using an HTTPS security. I have an SSL connection, very well. But I have an open wireless authentication. Do you think that this is going to go ahead and safeguard my network? No, it is like you have locked all the windows but kept the door open and you are feeling safe that nobody can climb up the window and get inside because I've already locked the windows. Well, the security is as strong as the weakest link is. So layer 1, layer 2 are the one which needs to be most secure because your wireless network, the entire wireless network works on the layer 1 and layer 2. I'm assuming that the audience here is aware of the layers of OSI network. If not, then it simply is the 7 layers we talk about, which start from physical, then data, then network, then your IP, then session, then application, then presentation, and then finally application. So you need to be very clear about where are you targeting. If I'm talking about wireless, I'm talking about the physical layer as well as the layer 2 layer. Penetration testing. Well, I say that you say that your wireless network is secure and your wireless network cannot be penetrated. Well, then let me just go ahead and try out a DOS attack. Let me go ahead and use a simple tool and let me see whether I can go ahead and create a denial of service. Let me see that if I could go ahead and do a man in the middle. And if you are able to, or if your system or if your network is able to safeguard themselves from this kind of attack, well, then that becomes easier for you to, or fairly safe for you to say that, you know what, this thing worked out for me. In an organization, wireless security policies are very important. And from the background I've come from, we used to go ahead and troubleshoot wireless devices a lot. And we always used to be worried whenever a new group or a new wave used to come and hit the floor. Plain and simply because these new guys used to go ahead and try to test the wireless network right at that time that, you know what, let's see whether we are able to go ahead and do that. And they used to simply go ahead and push the wireless network, our organization wireless network, off a new access point without any security. Well, you can also debate about it that what are the odds that somebody would be actually going ahead and looking and at that time would like to hack you. The odds are that if somebody is after you hacking, then he or she would be waiting patiently. Like I said, a hacker has the ability to wait patiently. So your policy should be strong enough that you don't create a backdoor or a loophole in your security. And finally, government and industry regulations are there. Now all the hotspot necessarily have to have an authentication policy. Finally, we also have this intrusion detection and prevention system. Most of the 500, I would say OEMs, Fortune 500 OEMs have an IPS and an IDS device to, from a Mac perspective, to go ahead and make sure that they are auditing the Mac, and whatever Mac is something which is not aligned to their own data table, they simply send a the audit to them. Here are in a nutshell the table for the type of use, the audit, the attacks, and the tool which are very well available. As a matter of fact, I just pushed off my Kali. Otherwise, let me see if I can go ahead and fire it up. I don't think so. There's any other things to go ahead and share. But once this is shared, I guess the time is up now. So I'll just go ahead and share this to you, and then we'll go ahead and close with the session. So these are the wireless security audit, and these are the various attacks and the tools which are there. You don't have to cough up a lot of money. All of these attacks tools are free of cost completely. These are the system intrusion and as well as the prevention system. And finally, I'll leave this podium open for any kind of question. By the time I go ahead and fire up my colleague, I would be ready to go ahead and answer any question, whatever you guys have. Please. Guys, any question? Hello? Anybody? Any question? So what we are going to do here right now is I'm trying to go ahead and simply show you the various tools which are available to go ahead and do the necessary. Let us be positive, necessary penetration testing and not the hacking part, and see how safe your actual network is. I also know the time is up, so people who would like to log off can log off. I've already shared the slides to Ayush. The one who are interested, uh, they can stay back. And like I said, I'd like to work with Ayush if we could have another session wherein we simply demonstrate uh, the, the various attacks we have discussed. We'd like to demonstrate the denial of service attack. We'd like to demonstrate the man in the middle attack, the fake AP attack, so that we could go ahead and get a fair overview of what basically when we talk about a DOS or a man in the middle is, and how does it looks in a real world life scenario. I'll get back to the questionnaire till the time it boots up. Okay. Yeah, I just checked up. I pinged Ayush to find out whether there are some people still left or I'm the only one talking to myself out here. So I know I'm good into this, and I'm very passionate about wireless, but trust me, I'm sure I've not been so much clear enough that all of you have got everything. I'm sure there would be some questions here and there. And none of the question, trust me, is something which is, let's say, stupid or should not be asked. Go ahead. This is your platform. Utilize it. If you have any queries, put forward. So, by the time this boots up, how many people would like to actually go for this? Let's say, let's put a flashy topic to it so that we could actually gather more audience. How many would you of you would like to actually go for a live demonstration uh, of a of a wireless attack, or let's say of a Bluetooth low energy sniffer, to check out how does a Bluetooth low energy packet hops? How many people are interested into it? Okay, great. I hope you are able to see the Kali screen. Utkarsh, how would you suggest a newbie to start with cybersecurity? Well, good question. Utkarsh, start with the fundamental of cyber. The security would definitely come to you. And what I mean is, what constitute a cyber? It's a mix of your web GUI, your user interface, your device on which the user interface has been operated, the device which is connecting wirelessly to an access point, and there would be a router behind it. And once you start going layer by layer, you're going to realize out the kind of vulnerabilities each and every protocol has. So not that these protocols are something which are useless, but basically these protocols are something which uh, would would actually create an issue unknowingly. So here is, since we are talking about wireless, see, these are the various wireless attack you can think of: air crack, chirp, cow patty, kismet. Kismet is a long timer. I remember when I attempted my CWN a long time back, 2005. I don't know what the year was, but that's a time when we used to work on kismet, and it's a good device. It's a very good software. It really helps you out into getting that kind of connectivity which you are looking in for, or basically get the information gathering. Then you have the radar, Java Snoop, and whatnot. Similarly, you have information gathering tools. You've got a vulnerability analysis tool, and time. And like I said, I'll work with Ayush for another such kind of a session. And I would really like your feedback as to whatever it was in terms of, let's say, uh, uh, yeah, Utkarsh, we kind of give similar kind of trainings on this. Yeah, you can definitely have few of them. Let me be very clear about it. And I had some discussion with Ayush on the same, so I'll pretty much check out with him how much we can go ahead and together work on this. And with the enthusiasm there, I can definitely go ahead and take a few of these sessions. I definitely want you all to be successful, and for that, if the basics are not if the basics are required to be strong enough, and definitely whatever help I can be, I'd like to go ahead and be that help. Thank you so much for your time. Thank you all, and you all have a good weekend ahead. And let me know whatever I can go ahead and do from my end to make it more successful. Please provide your feedback so that I can go ahead and work and improve myself on anything, whatever you feel, be it delivery, be it audio, visual, video, or recreates or whatever. Thanks, Ayush, for setting this up, and thank you for the opportunity. And I would like to go ahead and close the session now. Thank you. Have a good day. Bye bye.